when a ground fault circuit interrupter, or GFCI, trips as soon as the light bulb is installed. Even though the circuit holds fine otherwise, several potential causes should be investigated. Firstly, a damaged or incorrect light fixture could be the culprit. It's imperative to ensure that the light fixture is securely attached and is rated for the correct voltage and amperage for the circuit it's connected to. Incompatibility or internal damage within the fixture itself can lead to GFCI tripping. Secondly, loose connections within the wiring can create intermittent disruptions that cause the GFCI to trip. Every wire connection in the circuit, including those at the fixture, switch, and within the electrical panel, should be meticulously checked to ensure they are tight and secure. Loose connections can cause arcing, which the GFCI can detect as a ground fault. Thirdly, the GFCI itself may be overly sensitive. GFCIs are designed to trip when they detect a very small imbalance in current, indicating a potential ground fault. Sometimes a GFCI can be too sensitive and trip unnecessarily. As a first step, try resetting the GFCI by pressing the test and reset buttons. If the GFCI trips immediately again after resetting, replacing the GFCI is a reasonable next step to rule out a faulty device. Fourthly, the circuit may be overloaded when the light bulb is installed, which could cause the GFCI to trip. Although the circuit holds fine without a load, the addition of the light bulb might push the circuit beyond its safe operating capacity. To assess this, check the load capacity of the circuit, typically 15 or 20 amps, and ensure that the total load, including the light bulb and any other devices in the circuit, does not exceed this limit. Overloaded circuits are a fire hazard and should be addressed immediately. Fifthly, a ground fault in the wiring or the fixture itself can cause the GFCI to trip. A ground fault occurs when current leaks from a hot wire to a grounded part of the circuit, such as a metal junction box or the grounding wire itself. Use a voltage tester, or preferably a multimeter, to check for any ground faults in the circuit. This involves testing the voltage between the hot wire and ground at various points in the circuit to identify any unintended current leakage. Sixthly, a faulty switch could be the reason for the GFCI to trip. The switch may be malfunctioning internally, causing a ground fault when the load is added. To rule out the switch, replace it with a new one and then test the circuit to see if the problem persists. The troubleshooting process should involve a systematic approach to identify and resolve the issue. 1. Verify that the light fixture is indeed compatible with the GFCI circuit. Check the fixture's voltage and amperage ratings to ensure they match the circuit's specifications. 2. Check all wire connections meticulously, ensuring they are tight and secure. Pay close attention to connections at the light fixture, the switch, and within any junction boxes. 3. Attempt to reset the GFCI by pressing the test and then the reset buttons. If it trips immediately, this indicates a high likelihood of a ground fault or a faulty GFCI. 4. Measure the circuit load using an ammeter to ensure that it does not exceed the rated capacity of the circuit, typically 15 amps for a 15 amp circuit or 20 amps for a 20 amp circuit. 5. Use a voltage tester or multimeter to check for ground faults in the circuit. Test the voltage between the hot wire and ground at various points to identify any unintended current leakage. 6. If you suspect the switch is faulty, replace it with a new, known good switch to eliminate it as the cause. 7. If the problem continues even after trying all of these steps, consider replacing the GFCI itself. It's possible that the GFCI is faulty or overly sensitive. Safety is paramount when dealing with electrical circuits. Always turn off the power to the circuit at the breaker before performing any work. Use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to consult a qualified electrician to diagnose and repair the problem. Furthermore, it is important to understand how a GFCI works to effectively troubleshoot tripping issues. A GFCI constantly monitors the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current returning through the neutral wire. If there is an imbalance, meaning some of the current is flowing through an unintended path, such as through a person to ground, the GFCI will trip, quickly cutting off the power to prevent electrical shock. The sensitivity of a GFCI is typically set to trip at a current imbalance of 5 mA or less. This very low threshold makes GFCIs highly effective at preventing electrical shocks. However, it also means that they can be prone to nuisance tripping if there are minor current leakages in the circuit. When troubleshooting a GFCI tripping issue, it's helpful to isolate the problem by systematically disconnecting devices and sections of the circuit. For example, if the GFCI trips only when the light fixture is connected, the problem is likely related to the fixture or its wiring. If the GFCI trips even with the fixture disconnected, the problem is likely in the wiring between the GFCI and the fixture. Another useful troubleshooting technique is to use an insulation resistance tester, also known as a megameter or megger. This device applies a high voltage to the circuit and measures the resistance of the insulation. A lower insulation resistance indicates a potential ground fault or short circuit. However, using a megger requires caution and proper training, as the high voltage can damage sensitive electronic devices. When dealing with electrical issues, it's also important to be aware of the relevant electrical codes and regulations. The National Electrical Code, or NEC, provides detailed requirements for electrical installations, including the use of GFCIs. Local codes may also have additional requirements. Ensuring that all electrical work complies with these codes is essential for safety and compliance. In addition to the specific steps outlined above, there are some general best practices to keep in mind when troubleshooting electrical circuits. Always work in a well-lit area and use appropriate tools for the job. Double-check your work to ensure that all connections are secure and that there are no exposed wires. If you are unsure about any aspect of the troubleshooting process, seek the advice of a qualified electrician. Electrical work can be dangerous, and it's always better to be safe than sorry. If the GFCI tripping issue occurs in a bathroom, kitchen, or other wet location, it's especially important to address the problem promptly. GFCIs are required in these locations to protect against electrical shock hazards, and a malfunctioning GFCI can leave occupants vulnerable. When replacing a GFCI, be sure to choose a replacement that is rated for the same voltage and amperage as the original. Also, follow the manufacturer's instructions carefully when installing the new GFCI. Some GFCIs have different wiring configurations, so it's important to ensure that the wires are connected correctly. If the GFCI tripping issue is intermittent, it can be more challenging to diagnose. In these cases, it may be helpful to use a circuit analyzer, which can monitor the circuit for voltage fluctuations, current imbalances, and other anomalies. A circuit analyzer can help to pinpoint the source of the intermittent tripping. When troubleshooting a GFCI tripping issue, it's also important to consider the age of the wiring. Older wiring may have deteriorated insulation, which can lead to ground faults. If the wiring is very old or damaged, it may be necessary to replace it to resolve the problem. Replacing wiring can be a complex and expensive undertaking, so it's best to consult with a qualified electrician to assess the situation and determine the best course of action. In some cases, the GFCI tripping issue may be caused by a combination of factors. For example, there may be a minor ground fault in the wiring, coupled with an overly sensitive GFCI. In these situations, it may be necessary to address multiple issues to fully resolve the problem. When troubleshooting a GFCI tripping issue, it's always a good idea to document your findings. Keep a record of the steps you've taken, the results of your tests, and any repairs you've made. This documentation can be helpful if the problem occurs in the future, or if you need to consult with an electrician. Troubleshooting electrical problems can be a challenging but rewarding task. By following a systematic approach, using appropriate tools and techniques, and prioritizing safety, you can often identify and resolve GFCI tripping issues and ensure the safe operation of electrical circuits. Remember to always turn off the power at the breaker before working on any electrical components, and consult a qualified electrician if you are unsure about any aspect of the troubleshooting process. The issue could also be related to the type of light bulb being used. Some energy-efficient light bulbs, such as compact fluorescent lamps, or CFLs, and light-emitting diodes, or LEDs, can sometimes cause GFCI tripping due to their electronic components. try using a different type of light bulb to see if that resolves the issue. If the GFCI only trips with certain types of light bulbs, it may be necessary to use a different type of bulb or to install a GFCI that is specifically designed to work with those types of bulbs. It's also possible that the GFCI tripping issue is related to the neutral wire. A loose or disconnected neutral wire can cause current imbalances that can trip a GFCI. Check the neutral wire connections at the GFCI, the light fixture, and the electrical panel to ensure they are tight and secure. If you find any loose or disconnected neutral wires, reconnect them and then test the circuit to see if the problem persists. In some cases, the GFCI tripping issue may be caused by a shared neutral wire. A shared neutral wire is a single neutral wire that is used by multiple circuits. Shared neutral wires can cause current imbalances that can trip a GFCI, especially if the circuits are heavily loaded. If you suspect that a shared neutral wire is causing the problem, you may need to separate the circuits and run separate neutral wires for each circuit. This can be a complex and time-consuming task, so it's best to consult with a qualified electrician to determine the best course of action. Another potential cause of GFCI tripping is electromagnetic interference, or EMI. EMI is electrical noise that can be generated by various devices, such as motors, computers, and fluorescent lights. EMI can interfere with the operation of a GFCI and cause it to trip. If you suspect that EMI is causing the problem, try moving the GFCI away from any potential sources of EMI. You can also try using a line filter to block EMI from entering the circuit. If the GFCI tripping issue only occurs during certain times of the day, it may be related to voltage fluctuations in the power grid. Voltage fluctuations can be caused by various factors, such as heavy loads on the grid or problems with the power company's equipment. If you suspect that voltage fluctuations are causing the problem, you can try using a voltage regulator to stabilize the voltage to the circuit. When troubleshooting a GFCI tripping issue, it's also important to consider the environment in which the GFCI is located. GFCIs are designed to be used in dry locations, and they can be damaged by moisture. If the GFCI is located in a damp or humid environment, it may be necessary to replace it with a GFCI that is specifically designed for wet locations. In addition to the troubleshooting steps outlined above, there are some additional tips that can be helpful. Use a flashlight to carefully inspect the wiring and components for any signs of damage. Take pictures of the wiring and connections before disconnecting anything, so you can refer to them later. Label all wires before disconnecting them, so you can easily reconnect them correctly. Use a wire stripper to remove insulation from wires without damaging the wires themselves. Use a torque screwdriver to tighten wire connections to the proper torque. When replacing a GFCI, be sure to recycle the old one properly. GFCIs contain electronic components that can be harmful to the environment, so it's important to dispose of them responsibly. If you are not comfortable working with electricity, don't hesitate to call a qualified electrician. Electrical work can be dangerous, and it's always better to be safe than sorry. In conclusion, troubleshooting a GFCI that trips when a light bulb is installed requires a systematic approach and attention to detail. By following the steps outlined above, you can often identify and resolve the problem and ensure the safe operation of electrical circuits. Remember to always prioritize safety and consult with a qualified electrician if you are unsure about any aspect of the troubleshooting process.